This university found a new way to repair corroded infrastructure without tearing it apart. Across the country, corrosion is slowly eating away at the bridges, steel components, and beams that millions of people rely on every day. Traditional repairs like bolting on steel plates or replacing the entire beam are slow, expensive, and disruptive. Researchers at UMass Amherst, in collaboration with MIT, are exploring different approaches.
What we did is look into actual additive manufacturing technologies, and what we actually started seeing is a cold spray doesn't really affect the parent structure, so being the actual beam, and it allows us to spray metal on the corroded substrate in a very efficient, localized manner. A lot of corrosion is really happening on the lower side of the beam. We got water coming down, maybe even including salts because of broken joints, for example, and it really affects the lower side of these beam ends, and that's where you want to be with your cold spray.
So what happens if it goes untreated?
A lot of these bridges have a service life 50 to 100 years, and what she's actually seeing right now is that a lot of these bridges are reaching end of life. What that means is replacement is needed. So if you come with methods that can try to extend life of bridges, it's going to be huge.
Simmons, could you tell me how M2I2 has impacted our work?
Yes, so our work has been focusing on repairing steel corroded bridges, and we have done a lot of work the last 10 years in the lab, in actually many different labs within UMass and MIT, as you can see here. M2I2 has been pivotal in our research because it was given as an opportunity to us to buy this piece of equipment, which is like a portable 3D printer. It's a cold sprayer, and this allowed us actually to move our technology from the lab to the field. Our field is repairing steel bridges, and the work needs to happen on the bridge, and this cannot happen without a machine like this. We heard about M2I2 from our collaborators at MIT. They had received some funding in the past, and we found ourselves 2 years ago in this position where we had a lot of this cool technology that was being developed here, but it was impossible to get it out of the lab to a bridge. For us, this is very critical. By this equipment, we were the first ones to actually apply this technology on a bridge while the bridge was actually in operation. So last May 2025, we had this big milestone in our research using the equipment that was bought from the M2I2 grant to actually spray on a bridge and apply this technology for the first time ever on a bridge in Great Barrington. So it could not have been more important for us to get an equipment like this one. And M2I2 made it happen.
This company makes windows using most thermally insulating materials on Earth. Windows have come a long way over the last 100 years, from the inefficient single-pane windows of the 1900s to the modern multi-pane window of today. There have been huge improvements, but still window remains one of the weakest points in a building's thermal envelope. Compared to insulated walls, modern windows still allow significantly more heat gain loss throughout the seasons. Aeroshield, born out of MIT, is exploring a new approach that could change the game.
We are working on a transparent aerogel material that can drop inside of windows and insulated glass as it's being made to cut energy losses in half.
But what is an aerogel?
An aerogel is anything that is more than 50% porous, and those pores have to be smaller than 50 nanometers on average. So this means that, when you think about a porous material, normally those are pores that we can see, and when you break open the material, you can see those little holes. An aerogel is going to have pores that are orders of magnitude smaller than visible light, which gives it really unique combinations of properties. And in Aeroshield's case, we make a silica aerogel that enables it to be super insulating and ultra clear.
But what does it mean for average person?
The idea is that if you have, like 90% of homes, a double pane window in your home, we can attach just 4 millimeters of this aerogel material to one piece of glass, and that will stop 65% of the heat loss going through your window. If you're a homeowner, that would translate to as much as reducing your energy bill by half. So it can have a really big impact on what you pay day to day.
We checked out some of their aerogel scrap, and it's not what you expect.
And so it's very flexible, but people think about glass materials and you think, oh, it's very brittle, which cantilever material is very brittle, but it's also much more flexible than people would expect. So it can deform a lot more, which is good because that means once we put this material inside of a window, the glass in the window might deform due to wind, due to pressures, and this can flex way more than the window. And so once we have it protected inside, it's very stable.
In January 2024, Aeroshield received a $610,000 M2I2 grant from the Massachusetts Center for Advanced Manufacturing. This grant supported the manufacturing of their cutting-edge insulating transparent inserts for windows. Here's what Cal said about their experience with M2I2.
From what what I see, and sort of also like what M2I2 helped us do, is really continue as a company to transition from something that was at MIT a very R&D based project. At MIT, we were making, these 6-inch rounds where you could measure this incredible properties, and we're able to use that to convince ourselves that this product could change how we use energy in our buildings and change the performance of our windows. But ultimately, this is not a window. And there's so many other things around what a window needs to be in terms of its optical properties, thermal properties. How do you actually design and build this repeatably? That really aren't something that you think about in an academic setting. And throughout Aeroshield's sort of development and course, I think getting closer and closer to really understanding what does it mean to have a window product that will get installed. We've continued to, I think, make that transition from R&D to a company that can sell a real product. And M2I2, I think, was critical in helping us build out this step that you see here, where we're now actually producing something that looks like and is the same size as what we need to sell to our customers.
This company makes underwater robots that clean ships. From groceries to gasoline, global shipping delivers the essentials we depend on every day. And that efficiency starts with a ship's hull. It determines how smoothly a vessel moves through water, how much fuel it burns, and how long it can stay in service. Over time, a ship's hull is affected by biofouling, which is, well, I'll let Anjali explain.
So biofouling is basically the buildup of organisms or algae on the surface of some type of substrate. It can be, a coating, a vessel, it could be a bridge, whatever's in the water. Typically, if anything's in the ocean, there's stuff that's going to grow on it, and that's what we consider biofouling.
Since these ships stay in the water for years at a time, small amounts of biofouling, called microfouling, is constantly happening, which means ships need to be cleaned frequently. But the traditional methods are slow, costly, and inconsistent. Fleet Robotics is exploring a different approach.
The original nexus of the idea was around this concept of eliminating downtime for large infrastructure assets. Our idea was, could we add these autonomous robotic endpoints that continuously crawl around these assets and give you real-time data and ability to respond to issues in real time.
So they are designing a swamp of robots to crawl around the ships and clean its hull. But how do you make a robot stick to the side of a ship?
This is an EPM, or electropermanent magnet.
So each robot has 12 of them, 6 on each side, that it uses to adhere onto the surface. So as it's walking, one side stays adhered, the other one is lifting and moving, and it basically just steps. It has like 6 toes, if you will.
And these EPMs are really strong.
I think we did the math, it's like about 3 cows. We could lift 3 cows with the robot, roughly.
As these robots crawl around the ship, they scrub away the microfouling, but they are doing something else too.
Every step we're taking on the vessel, we're collecting data on coating thickness, just hull integrity data, and that's part of the value proposition that we have with ship owners. It's not just keeping your ship clean, but also the enormous amount of data and insights that we can capture that aren't currently available.
In January of 2025, Fleet Robotics received a $365,000 M2I2 grant to construct its autonomous robotic systems for maritime maintenance. With this grant, Fleet will build 5 robots and deploy them at the port of New Bedford to construct a new in-water testing platform. Fleet plans to add up to 3 new jobs as a result of this project. This company tests how spacecraft and satellites survive in space before they even leave the Earth. Satellites, spacecraft, and critical electronics only get one chance to survive the radiation, vacuum, and electrostatic discharge of space. And proving the hardware will survive has traditionally been slow, expensive, and uncertain. Electromagnetic application is changing that.
EMA here in Pittsfield, and the lab that we're in, specifically focuses on what we call spacecraft survivability. Is the thing that you're sending to space going to survive the time duration and the location in space that it is? And we use our equipment to replicate the radiation profiles that you'll see at different parts of space and make sure that the equipment there behaves in a way that you'd expect and you don't get bad results or anything like that.
But why is this important?
Everything in space relies on solar cells. It's the only power that you can bring with you is what you have up there, right? And over time, the optical coverings and things, they darken. Electrostatic discharge can happen from space radiation effects. And being able to just have a playground for companies to be able to come in and do that was kind of what we were after here. And what you see here is kind of the culmination of it. Like, science isn't always pretty, right? But lo and behold, I mean, we have protons and electrons and we can move things in and out of it there. And we really haven't run into a test we can't run, all because we were able to get a really well-rounded suite of equipment to make this possible.
In 2021, EMA received a $429,000 M2I2 grant from Massachusetts Center for Advanced Manufacturing. The M2I2 grant provides state funding to help Massachusetts innovators start manufacturing their hard-tech technologies. Here's what Justin said about his experience with M2I2.
One of the challenges with any small business is growing is really painful. It's very expensive. It takes a really long time if you're going to do it organically. And for EMA, we've typically been just a group of really big experts. Like we have such deep expertise in really hard technical areas that when you grow a company, you need infrastructure, right? And so for us to choose infrastructure or equipment, it's not a solvable problem here. And so by having outside grant capital like what M2I2 provides, it makes that an easy case where we have the funding in place to buy the things we need. I think we were a $3, $4, or $5 million revenue company at that time. So we're talking about $500,000 in purchases that needs to happen kind of in a big bucket. And that's just, you don't have that money laying around in your checking account. So it becomes something that we have to draw out longer time durations there. And sometimes the business opportunity just evaporates when you can't do it. So the whole M2I2 experience for us was really easy. The grant process was straightforward. We got terrific guidance from all the folks at Mass Tech that reviewed it and told us kind of how we needed to do it. And realistically, I wish more companies did this, right? Because it's just such a powerful resource to have when you're trying to grow something here at Mass.